So phase one parameters are NAT-Traversal enabled or not, and we'll go into detail on each of these. The pre-shared key for authenticating between the two devices, basically a shared password. What's called the IKE Internet Key Exchange Peer ID, which is often not used. Phase one algorithm, phase one hash, phase one Diffie Hellman Group, which has to do with how key exchange happens, and the phase one lifetime. All of the connections to a given VNS cubed have to either be native IPsec or NAT-Traversal. If in the case it might be a customer, multiple data centers connecting in cloud with different networking teams, and one of them wants to use NAT-T, one of them wants to use native IPsec. As I mentioned, the initial negotiations occur on UDP 500, and then really the only difference between these is NAT-Traversal causes the IPsec protocol to be encapsulated in UDP 4500 because the connection isn't on the internet edge, and lots of network gateways can't protocol forward. They can port forward, but they can't protocol forward, so you have to encapsulate the IPsec traffic. If the device you're communicating to is on the internet edge or is behind a device that can do protocol forwarding, you can use native IPsec, and then that uses protocol 50 again. It's not port 50, and you'll see it if you've ever set up the Amazon VPC security groups. The security groups, you can have UDP rules, custom UDP rule, custom TCP rule, and then you can also pick custom protocol rule. So one thing that's important to remember is NAT-Traversal has NAT in the name. It doesn't really have anything to do with NATing your application traffic. It just specifies whether the communication between the two devices on the outer edge are going to go via UDP 4500 or protocol 50. Pre-shared key. So this is the easiest form of interoperability. It's for authentication between the two devices. It's effectively a shared secret. So if you think about it, you set up your VNS cubed, you set up your security groups, and we covered in the best practice guide, if the partner you're connecting to, let's say, is their device is at a public IP of 66.66.66.66, you should set up the security group to say, I'll accept UDP 500 and either UDP 4500 or protocol 50 from 66.66.66. And he should do the same on his device. He should only allow that protocol from you. So that basically takes care of most of the sort of security concerns. But you want to be able to have a pre-shared secret to differentiate between different connections, and that's what's called pre-shared key. It needs to be identical on both sides. The number one reason for pre-shared key issues is copy-paste. If you're going to use copy-paste, you need to be using a absolutely plain text editor that does not support any formatting characters, any invisible characters. Today, in most implementations, we're starting to see the standard does support effectively your side to have one secret and the other guy's side to have another secret. So you effectively would have, kind of think of it as if the cloud is up and to the left and the data center is down and to the right, effectively a left PSK and a right PSK. The Internet Key Exchange Peer ID, or IKE Peer ID. We have this concept of local private IP. What this is two things. Local private IP is the private IP used by NAT-Traversal. So some boxes, an example is a Watchguard Firebox. The Watchguard Firebox has to know the IP address of the device that it's connecting to, not only the public IP, but the private IP. So if you brought up a new VNS cubed, and so the Watchguard has to be configured with our local private IP. If instead of our local private IP, you were configuring the Watchguard with the actual private IP of the VNS cubed, the next time you brought up a VNS cubed for this topology, if you have to migrate or Amazon killed your instance or something, if you didn't bring it up on this exact address, the partner would have to edit their configuration, right? Which could be catastrophic. So what the local private IP is it's a persistent private address that regardless of what VPC address you have, it's what the other side can be told to use for that setting on their side. So it's a way to give you better configurability without any changes to the configuration in the event of a change. Where you see this on VNS Cubed is you see the local private IP address. So that's what local private IP does in part. We also use the local private IP as the IKE Peer ID. The customer will sometimes want to know what your remote peer ID is. From their point of view, you're remote. From your point of view, they're remote. So you need to know from which point of view you're talking about. So on boxes, some boxes, I think you'll see this in the Juniper document. You'll see on their web UI it says local peer ID, which from the customer side, the Juniper side is its side, and remote peer ID, that's you. So what will happen is when somebody needs that local private IP for the configuration to work, they're going to put it in their device under the setting called remote peer ID. So the key, most times this isn't explicitly needed, but I know, for example, Watchguard Firebox it is, and we run into that occasionally. It is needed for VNS Cube to VNS Cube connections, actually, and I'll show you that in a moment. Phase 1 algorithm basically is just the encryption algorithm that's going to be used in the Phase 1 communication. Sometimes people will call it ISA KMP. Sometimes they call it IKE. There's basically very limited choices. Your choices are AES 256, AES 128, and 3 DES. And this comes out in the section in extra params where the extra parameters box where you'll specify Phase 1 equals. The other part of the Phase 1 communication is the hash. And this is a hash function that's used as part of the encrypted communication. So the more newer boxes and more newer connections, people might be asking for SHA-2 as opposed to what was, sort of these are in order of security. MD5 is not used really hardly at all today. You'll run into that with an older box. You'll have a customer who has an out-of-life, end-of-life box, and they're going to ask you for 3 DES MD5, and then we'll see the Diffie Hellman's DH2. And was state-of-the-art probably when that box was made, but they haven't been able to upgrade it. So MD5 is not used very often. SHA-1 is what most people use today, but people are starting to move to SHA-2. And SHA-2 comes in 2 flavors, 256 and 512. And so there you need VNS Cube 35113, which is what we're giving you when you set up new instances today. So it has to be 35113 and above to have access to that. Phase 1 Diffie Hellman, again in order of security. There is an 18 that some people are using now. We're seeing a move to 14, but most of your connections are going to be 5. And these literally just represent, each of these represents actually a byte specification of how the algorithm and the computation is done. And then Phase 1 lifetime. Phase 1 lifetime is most commonly done in seconds. It's every now and then somebody will say 8 hours or 24 hours, but they usually give you a large number, and that's in seconds. You have to match what the customer has to have a stable connection. So we will take, VNS3 takes the first thing that the other side offers. So whatever they offer, we'll agree to. We don't push our own thing on them. We say whatever you tell us first. So what you want to have in extra params box is matched to whatever it is they're asking you for first. So they tend to be 3,600 seconds, 28,800 seconds, and 86,400 seconds. So 1 hour, 8 hours, and 24 hours. There's no rule that you couldn't use a different number of seconds. It's just not commonly done, and there's probably some boxes who would fail if it's not one of these functions that as you talk to them.